This is Summary Notes Chapter 4. We're taking a look in this particular video, the sublevels of energy that are within an atom's main level of energy. In the previous episode, we took a look at main levels of energy that can be seen when we take the spectra of a particular element, and it shows up as a set of lines, colored lines, that is unique to that element. All right, sometimes if you go see fireworks, they hand you some spectral glasses so you can see the different wavelengths of light that make up all the elements in fireworks, and it's really spectacular to see. All right, we're going to be drilling down a little further in this video to take a look at main levels of energy sublevels of energy within main levels. All right, so as we move away from the nucleus of the atom, its volume does get larger. Suppose this is the nucleus. I'll put a letter N there. All right, and then as we'll look at an old school model of an atom, as we move out from the nucleus, all right, obviously the volume gets larger and more things can fit in the space around that nucleus. All right, so in the space that's directly next to, not directly next to, but the probability of a volume of space that's around the nucleus itself, there's room for one sublevel of energy, and that is called S. Okay, and this S sublevel is represented by this yellow box as an orbital diagram. All right, so this is an orbital diagram when you see these boxes, and they do refer to orbitals. Okay, so these are orbital diagrams that you see for each of the main levels that are represented here. All right, and at the lower part of the picture, you can see a shape for this orbital. All right, the 1s being closest to the nucleus. And there's about a 90% chance of finding an electron in this volume of space. All right, so 90% probability. And as you go out to other main levels of energy, each main level of energy starts with an s orbital. So that's why you see 3 here. It doesn't go up to 4s in the bottom picture, but you can see an n equals 4 in this upper picture and another yellow box. All right, that yellow box representing the s orbital in an atom. Okay. Interestingly enough, there is a p orbital sublevel, and that has 3 orbitals at the p sublevel, so that's why you see 3 connected green boxes there. As you go out even further, there'll be d sublevels of energy that can fit on the 3rd main level. And if we go out even further still, we'll see that there are an f sublevel of orbitals as well, and that happens to be 7 of those. So there's 1 s orbital in the s sublevel. There's 3 orbitals for the p, there's 5 for the d, and there's 7 for the f. All right, now let's take another look at some pictures here. All right, we just saw the s orbital shape. All right, it takes the lowest amount of energy to maintain a spherical shape. I just think if you don't exercise, we get kind of rotund if we don't exercise and use a lot of energy to maintain our shapes. So if you think about that, these orbitals might make a little more sense to you. All right, and also think about these sublevels are nested within each other. So if we take a look at the p sublevel, all right, notice that we see 3 orbitals here. We see an orbital that lies along the x-axis, one that lies along the y-axis, and they have the z-axis straight up and down in this picture. All right, and then you see them all together. But inside there, that S sublevel is there. All right, we try to show them separately so you get an idea of what the orbitals look like by themselves, but just know that they do, it's kind of like an onion, where each layer of the onion is one of the main levels of energy, and within that main level of energy, you have these sublevels. All right, then take a look at how complicated the d orbitals are. There are 5 d orbitals. And this is the shape that's most interesting to me because it's got this little donut configuration there in the center. All right, but this is a pair of lobes, and this is a pair of lobes. All right, just like you see up here in this p orbital where you see the two lobes here, we have 4 lobes that make up an orbital for the d sublevel. And the f orbitals are even more complicated still. There's 7 of those. And again, that your book doesn't even show these f orbitals, but I thought you should see them just so you could understand how much energy it would take to maintain these shapes. All right, and there are 7 shapes. All right, and all this information, the N, the main level of energy, the sublevels of energy, we're going to show you how well the periodic table is laid out because it has everything to do with the periodic table. All right, now some other interesting things about what we're seeing here with these orbitals. All right, remember in the previous picture we took a look at the orbital diagrams, the yellow, the green, the orange, and the violet orbital boxes that I mentioned. All right, well, something about those orbitals is that only 2 electrons can be in any orbital, maximum. At times there may be 1, but only a maximum of 2. 2 electrons in any orbital, and I don't care where it's located, S, P, D, or F, you can only have 2 electrons there. And they're going to occupy some place within that orbital, but they'll also have opposite spins from each other. So we denote that by doing an arrow up and an arrow down. And I only do half an arrow ahead just to make it less, well, easier to see, I guess it would be a good way to say it. All right, and within these orbitals, electrons literally spin around an axis, which is interesting to think about. And when they do that, they make a sound, a frequency of sound. And there's something called a watering hole out there in space, a watering hole, that a project called SETI actually listens for the frequency of these spinning electrons, because every once in a while that spin will actually reverse itself. And when it does so, it gives off a little frequency that the SETI Institute, the Search for Extraterrestrial Intelligence, is real. Carl Sagan was one of the founders of this. And they listen for these watering holes in space. So that's just an interesting little piece of trivia about electrons and spin. Again, there's 2 electrons in each orbital, regardless of the sublevel that you are at or the main level that you are at. All right, so here's a table showing this, a summary table showing the energy level. And I'll come up here and do a highlight. So at the energy level N is 1, it's closest to the nucleus. When you hear that N is 1, you can only have 1 sublevel, which is nice. 2 means 2 sublevels, 3 means 3 sublevels, and so on. All right, and then it tells you how many sublevels there are, as well as the order in which electrons reside. 1s sublevel has 1 orbital, 2 electrons. Okay, and 2 total electrons for the main level. All right, so that's what this last column is. Total electrons for the main level. So we go down to the second main level. See if I can pull up another color without it causing me too much difficulty. Yay! All right, so here's the second main level of energy. And notice it has 2 sublevels, the S and the P, and we saw that in the orbital diagram as well. The thing to remember is that the P sublevel has 3 orbitals. That means it has room for 6 electrons. That means for the whole main level, it has 8. Okay. And we'll just do one more sublevel. Let's get another color up here. This thing will come on. All right, we'll do this next one in green. Come on. All right, maybe we won't do it in green. It's misbehaving. All right, it's not doing what I want it to do now. It's doing it. All right, it figures. All right, so here we go with green on the third main level. There's 3 sublevels. All right, We already know 1 and 3 for the S and P. The D sublevel has 5. That can hold 10 electrons. A total for the whole main level is 18. Where have you heard that number 18 before? Take a look at your periodic table and see if you can find the number 18 at the top there, top right corner. All right, 18. All right, then we come down to this last sublevel that's showing. All right, and this last sublevel that's showing. All right, notice it starts all over again. S sublevel first, then the P, then the D, now the F. All right, the F sublevel comes in, and now look at how many electrons we can have at the fourth main level. All right, so 2, 8, 18, and 32. Those are a total number of electrons for this. And we have a few problems to try. All right, before we stop this one. All right, and so here it says indicate the type and number of orbitals in each of the following energy levels. All right, so if you want to stop at a moment and see if you can answer those questions, and we'll come back. All right, so if n equals 2, then we're talking about the S and P sublevels. All right, so that's the type of orbitals we're hearing. S sublevel means 1 orbital. P means 3. Okay. If we're talking about just the 4p sublevel, the 4p sublevel has 3 orbitals. Means the same thing. It means 3 orbitals only. Okay. If n equals 1, then we're only talking about the s orbital because that's all that can fit in the space closest to the nucleus. And then lastly, the 3d sublevel, see if I can squeeze that in down here, has 5 orbitals, 5d orbitals. And remember, regardless of where you find that orbital, you can have 1 electron minimum, 2 maximum. Okay, and we'll take a look at electron configurations in the next video.